Welcome to this model. In this model, we are going to discuss about the network types. In the previous models, we have discussed about the networks and their physical structure. Now we need to discuss different types of networks we encounter in the world today. The criteria of distinguishing one type of network from another is difficult and sometimes confusing. So we use a five criteria such as size, geographical coverage, ownership to make this distinction. And first, let us have a look into local area network. A local area network is usually privately owned and connects some hosts in single office, building, or campus. Depending upon the needs of an organization, LAN can be as simple as two PCs and a printer in someone's home office, or it can extend throughout a company and include audio and video devices. Each host in a LAN has an identifier, an address that uniquely defines the host in the LAN. A packet sent by a host to another host carries both the source host and destination host address. All hosts in the network were connected through common cable in the past, which means that a packet sent from one host to another was received by all hosts. The intended recipient kept the packet. Other dropped packet, and today most LANs use a smart connecting switch which is able to recognize the destination address of the packet and guide the packet to its destination without sending it to all other hosts. The switch alleviates the traffic in the LAN and allows more than one pair to communicate with each other at the same time if there is no common source and destination among them. The above definition of LAN doesn't define the minimum and the maximum number of hosts in LAN. Now we can see the structure of the local area network. It is an isolated LAN in the past and today, and these LANs are used in isolations which are rare in today, and they were designed to allow resources to be shared between the hosts. LAN today are connected to each other to WAN to create communication at a wider level. Next, let us move on to wide area network. A wide area network is also an interconnection of the devices capable of communication. There are some differences between a LAN and WAN. A LAN is normally limited in size, spanning an office, a building, or campus, whereas a WAN has a wider geographical WAN interconnects connecting devices such as switches, routers, and modems. A LAN is normally privately owned by the organization that uses it. WAN is normally created and run by communication companies and leased by an organization that uses it. Now let's see the two distinct examples of WAN today, that is point-to-point WAN and switch WAN. A point-to-point WAN is a network that connects two communicating devices through a transmission medium. WAN which connects the network to one another. So here is an example of a point-to-point WAN. And a switched WAN is a network with more than two ends. A switched WAN is used in the backbone of the global communication today, and we can say that a switched WAN is a combination of several point-to-point WANs that are connected by switches. So this diagram shows the example of a switched WAN. What we see here is the internetwork. So internetwork is today it is very rare to see a LAN or WAN in isolation. So they are connected to one another. When two or more networks are connected, they make an internetwork or internet. As an example, assume that an organization has two offices, one on the east coast and one other on the west coast. So each office has a LAN that allows all companies in the office to communicate with each other, as you can see in this diagram. So to make the communication between employees at different office possible, the management leases a point-to-point dedicated WAN from a service provider such as a telephone company and connects the two LANs. Now the company has an internetwork or a private internet, and communication between the offices is now possible. When a host in the West Coast office sends a message to another host in the same office, the router blocks the message, but the switch directs the message to the destination. On the other hand, when a host on the West Coast sends a message to a host on the East Coast, then a router R1 routes the packet to router R2 and the packet reaches the destination. Switching. An internet is a switch network in which a switch connects at least two links together. A switch needs to forward data from a network to another network when required. There are two common types of switched networks are circuit switched and packet switched networks. Now let us discuss both the circuits one by one. So this diagram shows the circuit switched network. In a circuit switched network, a dedicated connection called a circuit is always available between the two end systems. The switch can only make it active or inactive. So this is a simple switched network that connects four telephones to each end. We have used telephone sets instead of computers as an end system because circuit switching was very common in telephone networks in the past. Although part of the telephone network is made although part of a network is made as a packet switched network. The four telephones at each side are connected to a switch. The switch connects to a telephone that is set at one side to a telephone set at the other side. The thick lines connecting two switches is a high capacity communication line that can handle four voice communications at the same time. The capacity can be shared between all pairs of telephone sets. The switches used in this example have forwarding task but no storing capability. Let's look at two cases. In the first case, all telephone sets are busy. Okay, and four people at one side are talking with four people at the other side. The capacity of the thick line is fully used. In the second case, only one telephone set at one side is connected to a telephone set at the other side. Only 1/4 of the capacity of the thick line is used. This means that a circuit switched network is efficient only when it is working at its full capacity. Most of the time it is inefficient because it is working at a partial capacity. The reason that we need to make the capacity of the thick line 4 times the capacity of each voice line is that we do not want communication to fail when all telephone sets at one side want to be connected with all telephone sets at the other side. And the next is packet switched network, which is shown in this diagram. In a computer network, the communication between the two ends is done in blocks of data called packets. In other words, instead of the continuous communication we see between two telephone sets when they are being used, we see exchange of individual data packets between data computers. This allows us to make the switches function for both storing and forwarding because a packet is an independent entity that can be stored and sent later. So here a small packet switch network is shown that connects the four computers at one side to four computers at the other side. A router in a pocket switch network has a queue that can store and forward the packet. Now you can assume that the capacity of the thick line is only twice the capacity of the data line connecting the computers to the routers. If only two computers need to communicate with each other, there is no waiting for the packet. However, if the packets arrive at one router, when thick line is already working at its full capacity, the packet should be stored and forwarded in the order they arrived. The two simple examples show that a packet switched network is more efficient than a circuit switched network, but the packets may encounter some delays. And now let's move on to internet. The internet is composed of thousands of interconnected networks, and you can see the diagram of an internet. This diagram shows the internet has several backbones, provider networks and customer networks. So in the top level, the backbones are the large networks owned by some communication companies such as Sprint, Verizon, AT&T, NTT. The backbone networks are connected through some complex switching systems called peering points. At the second level, they are smaller networks called provider networks that use the services of the backbone for a fee. The provider networks are connected to the backbones and sometimes to other provider networks. The customer networks are networks at the edge of the internet that actually use the services provided by the internet. They pay fees to provider networks for receiving services. Backbones and provider networks are also called internet service providers. The backbones are often referred to as international ISPs, and the provider network are often referred to as national or regional ISP. The internet today is an internet network that allows any user to become part of it. The user, however, needs to be physically connected to an ISP. The physical connection is normally done through a point-to-point WAN, and today most residences and small business have telephone service, which means they are connected to a telephone network. Since most telephone networks have already connected themselves to the internet, one option for the residences and small business to connect to the internet is to change the voice line between the residents and business and the telephone center to a point-to-point WAN. So this can be done by two ways. That is, one is called dial-up service and the other is DSL service. The first solution is to add to the telephone line a modem that converts data into voice. The software installed on the computer dials the ISP and initiates making a telephone connection. Unfortunately, the dial-up service is very slow, and when the line is used for interconnection, it cannot be used for telephone connection. It is only useful for small residences. Since the advent of internet, some telephone companies have upgraded their telephone lines to provide higher speed internet services to residences or small business. The DSL service also allows line to be used simultaneously for voice and data communication. So more and more residents over the last 2 decades have begun to use cable TV service instead of antennas to receive TV broadcasting. So the cable companies have been upgrading their cable networks and connecting to the internet. A residence or a small business can be connected to the internet by using this service. It provides high speed connection, but the speed varies depending upon the neighbors that use the same cable. Wireless connectivity has recently become increasingly popular. A household or a small business can use a combination of wireless and wired connections to access the internet. With the growing wireless WAN access, a household or a small business can be connected to the internet through a wireless WAN. A large organization or a large corporation can itself become a local ISP and be connected to the internet. This can be done if the organization or corporation leases a high-speed WAN from the carrier provider and connects itself to the regional ISP. For example, a large university with several campuses can create an internet network and then connect the internet network to the internet. Thank you.